Good morning, everybody, and welcome to the latest in our series of webinars from Pilz. And this morning, we're going to be talking about safe machinery maintenance. And to introduce myself, my name is Alex Bryce. My co-hosts that are helping this morning in the background are my colleagues Jason Reed and Jamie Thomas, and they will be able to answer any questions that you might have if you use the chat box in the right-hand pull-down menu of the webinar. They will hopefully be able to answer any questions that you have as we go along. If not, we will basically be able to answer any questions following the webinar itself and catch up with you in the coming days. The slides are available. If you would like a copy of them, please just drop us a comment in the box and we will arrange to get those sent out to you. And as usual, our webinars are uploaded onto the Pilz GoToWebinar channel that you'll be able to go back and watch this should you need to for future reference. So the topics or the agenda for today are the maintenance requirements and standards. So we'll have an overview of that. We'll be looking at lockout tagout, or LOTO as it's known, and we'll finish by an overview of certain maintenance solutions that can be put in place to ensure that we can do things in a correct and a safe and controlled manner. So if we start off then with the maintenance requirements and standards, what is maintenance? Well, you know, the OED tells us it's the act of keeping something in good condition by checking or repair, and the act of making a state or situation continue. Wikipedia goes on to say certain extra bits, which I think are quite pertinent to what we're going to look at, where it then says that it involves functional checks, servicing, repair or replacing of necessary devices, equipment and machinery, building infrastructure and supporting utilities. That obviously covers a vast variety of things that you may come across in the day-to-day maintenance aspects of machinery and plant in the workplace environment. If we consider first the requirements of PUWER, so it's a legal requirement that machinery in the UK that machinery must comply with the regulation of PUWER. Regulation 5 specifically looks at maintenance. It talks about the frequency of maintenance and that a fault in a safety critical system could remain undetected unless you check things. So we'll be talking about frequency of checks and types of checks and things like that, and things that that involve or may decide how frequent the checks are or are needed. Will be based on how often the equipment is used. Is it something that's in permanent use 24/7, 365, or is it a piece of equipment that's used periodically for a certain function? What sort of environment is it in? You know, is it outside where it could get rained on? Is it a nice clean laboratory environment or whatever? Does it do different types of operation for different functions, different modes, etc.? What would happen? What would the risks be if something did actually fail? It also states that there's no requirement to keep a maintenance log, but for high-risk equipment, so where the hazards lead to something pretty dangerous, then it's recommended that there is a maintenance log, and if there is one, it should be kept up to date. And certainly there are different ways of looking at it, certainly from safety critical points of view, which could be planned preventative maintenance or condition-based maintenance, and we'll look at in a little more detail on these shortly. But also if it's hired, leased, rented equipment, something like that, then that also needs to be maintained, and that could also be the responsibility of the hire company rather than the end users and things that do that. But also a very key point, the final one, that maintenance should only be done by people who are competent to do it. So people have been trained what to do. in a maintenance situation, how to do it, what not to do, etc. Regulation 22 of PUWER looks a little bit more at the actual operational part of maintenance, and that maintenance must be constructed and adapted so that you can carry out maintenance in a reasonably practicable manner. So we're not we're ensuring as far as possible that we're not putting anybody in a dangerous situation with any risk to their own personal health and safety. So with things like LOTO, lockout, tag out, which we will look at in future, can ensure that the machinery is in a safe and contained condition to allow us to do that maintenance that is required. There may be maintenance requirements and timings and things like that as given by the machinery manufacturer. If for whatever reason there are certain residual risks and things like that that are required, then we need to be able to stop parts of equipment or allow other parts to run under controlled conditions and things like that. So it might be that we have to have a slow speed or a hold to run device or something like that to allow us to rotate maybe spindles or something like that to drive things around in a controlled manner to get to a certain section that requires the actual maintenance task to be undertaken on it. To help us in this, back in November of last year, or just quite recently, there was a standard, a British standard that was launched, BS 14200, that will give guidance on maintenance. And looking at work equipment and pressure components and things like that, so allow us to decide and schedule the various tasks and things that need to be done. So we're going to just look at certain sections of this. We're not going to go through it in masses of detail. It's not a huge document, but it does give some very good introductions and guidance on how you can set things up for your maintenance requirements. Initially, it talks about classification of maintenance priority. So working out what the machinery functions and things are that you actually have in the workplace. So there are a couple of issues that you need to look at in the fact that does it have an effect on safety, but does it have an effect on reliability? Now, there are quite a few similarities between the two, and the reliability of safety components obviously is one thing when you're looking at guard switches, gate interlocks, sensing devices to protect limits and things like that that you have within there. It talks about setting up a maintenance plan and what a maintenance plan is, which obviously is the approach for the preservation of the machinery in its safe and efficient working state. And there are various different ways that we can do that. And it talks about assessing the equipment regarding its predicted operating life. So normally we'd expect something to run for a period of time before it either wears out or needs replacing or something like that that we've got within there before things start to deteriorate and a machine potentially may not run as it's expected to do so. And we need to look at how we can do this from an optimization point of view to make sure that we get the quality out of the machine and everything. We get the reliability so that it doesn't keep stopping and tripping and things like that, so we can keep production up, and the fact that we can interact with it in a safe and controlled manner. We must also continually monitor what we have to make sure that the things that are in place are still suitable and sufficient as per the requirements for the machinery that you're looking at. There are things that we can look at about the monitoring and the frequencies and things like that we have for planned maintenance. So as I've said, to ensure that it remains suitable and efficient, that it's carried out in a timely manner. So it might be that we can predict when certain things are going to require changing or lubricating or whatever it might be to ensure that they're operating as they are. But also we can look at trends and things and see that, you know, we might need to increase the frequency of preventative maintenance or something, because the current system, things are wearing out too much and causing safety or reliability issues, so we can do that. There might be changes in the machine. It might be that it's, instead of suddenly running just 8 hours a day, 5 days a week, it suddenly now is running 8 hours a day, 7 days a week. So things are going to change in the fact that it might wear out a bit quicker, or we turn the frequency up so that it runs faster. So there are various things that we're going to have to look at, and some of which will be provided by the OEM to say that certain things will need to be done to the machine because they know what they've got within there. But it should always be an ever-evolving process, and the fact that we need to be able to regularly monitor to ensure that what we have is still valid. In setting out a maintenance plan, there's different approaches, tasks and reviews and things that we need to look at depending on the machine and maybe specifically the function. So it might be that we've got planned maintenance, both predictive or preventative, that there's reactive maintenance or breakdown maintenance required, and things that you might have different or even maybe even all 3, 4 variants of that on the one machine, depending upon what functions it is you're looking at. There's various different tasks that you have to do. It could be a pre-use check, a daily inspection, or a periodic inspection every 6 months, 12 months, or something like that. And also, we need to be able to review it. So we need to look at the records, and we need to look at how people are interacting with it and what any root cause failures may be, etc., that we can then put things in place in other actions, maybe change the preventative maintenance or something like that to stop any constant failures and things that might be happening. There are terms there that we used in the maintenance approach, and the definitions of such are given in the standard. So planned preventative is activities scheduled on a regular basis to repair, renew or replace parts so that they prevent the failure. Planned predictive, so when we're looking at potential deterioration or things like that, as bearings might be starting to wear or something like that, then you need to be able to repair, renew and replace them before they fail. It might be reactive, that we can carry out things if there's a trigger or an alarm that goes off before we end up with a complete breakdown or failure. Or it might be that something has broken, there is a breakdown, and we need to replace a particular machine part, component or assembly or something to keep it back up and running again. There are various tasks for each of the procedures and things that we can look at, and the standard tells us that we shall record the required tasks, which might be an inspection or an intervention or something like that, so we know what we need to do, what we need to test, and so on. But also, one of the key things to consider, if you remember we spoke about PUWER, it might be a hired or leased piece of equipment, or it might be that you have a third party contracted to carry out the maintenance because you don't have an in-house maintenance department. But again, you should be able to look at the tasks and things that are required there to make sure they're still effective for the needs. And especially if it's been in place for a while, there may be certain things that need to be added, modified or changed to that agreement with a third party or a contractor or something that's doing that maintenance for you. So the types of tasks and things that are mentioned include daily or pre-use, so they're done maybe at the start of every day or every shift change or something like that, which might be checking the functionality of a machine. So it might be that, for example, we open and close a guard to make sure it works. We put an arm through a light curtain or something like that to make sure that it's operational. And wherever we do have this, then there's normally a little tick sheet or something like that right at the side of the machine where you can record the maybe the initials of the person that did the check and the date that they did it and so on. And also we need to ensure that any defects or anything that fails to operate as is expected is reported and it's remedied before the machine's put into use again. It might be periodic inspection. So in addition to what we were looking at with the daily or the pre-use checks, it's something that might mean that we've got to every so often break down parts of a machine to get into certain areas, to lubricate parts, or to you know, sort of grease bearings or whatever it might be. We can potentially look at mechanical sections that are behind fixed guards and things like that you normally can't easily get to, and you can then identify what needs to be done in that respect. It might also be that, for example, some things like light curtains, where there's guidance given from the HSE and in standards that talk about periodic test and inspection of those to ensure that the positioning of them is correct and that they basically will still perform the right function, because the safety distance hasn't changed, because the machine hasn't, you know, increased its stopping time over a period of time as things may wear and so on. And we can look at routine servicing. So again, it might be an annual thing that goes in there that based on an OEM's guidance, or it might be that because we've been recording various aspects of things that's gone through, and we can look and we can predict that, you know, things need to be changed within that specific time period and such, because of the historical data and the records that we've got from our maintenance logs, etc. So we can look at defining how often we need to do the certain tasks if it's not something that's provided in guidance from an OEM. And for those of us that are familiar with 13849, you'll see that the chart here looks very similar to that particular standard that talks about levels of integrity and safety control systems. But here, similar sort of things to work through from left to right, looking at the severity of any injury that might be occurred if the machine was to fail or break down or anything there. Look at the criticality, you know, how frequently is the machinery used, you know, and how, you know, what's the reliability issues from both a safety point and a production point of view. And then also external factors and things like that. So the environment that it's used in, both in the actual physical environment and the way that people are using the machine itself. So one of the key things here is to also ensure that we don't allow anybody to tamper or bypass safety guards and things like that. If there is a history of that, it's recommended that you increase the frequency of these checks to ensure that that hasn't taken place. So to do the scheduling and everything, but we also need to identify the tasks themselves and what needs to be done. And the way to do that is to do a risk assessment, and so that we can avoid any hazards that are there. What to know to do if a failure does occur, what harm is it going to give? How can we control any hazardous energies? And that again boils down to LOTO, which we'll talk about in due course. How we can maintain a cost-effective production, so we want to make sure that we can have as little downtime as is needed. And also that we can maintain any emissions and things like that that might come from machines, so LEV systems, etc. And these can be done based on the tasks that we've just spoke about, so be it daily or pre-use or periodic or routine servicing requirements. The schedule and its intensity and things should be taken into account, looking at things like what preparation needs to be done to make any repairs, or what resources do we need. So do we need padlocks, do we need chains to lock things out and tie things down, and so on. Is it something that differs from the normal operating limits of the machine? Do we need to sort of change things to make the machine work in a different way to allow the maintenance to be carried out? Any duty and load cycles that are there, any component failure times and things like that, so we know if something's recommended that it's going to wear out after so many operations that we can make sure we've got that. Most importantly as well, that the competence of the maintenance personnel is correct, so people are trained in how to do the maintenance. And then there may also be some site-specific requirements and things that are in there that needs to be done. So it could be confined spaces or hot work or something like that that's needed, that needs to be in the actual the scheduling and the tasks and things that are included in the maintenance requirements. So you have to have a document or the log for the high risk, certainly for high risk equipment, things like that. So we need to be able to identify the machine. So, you know, for example, its serial number or something like that. We need to have details of what inspections and tests and what the acceptance criteria is. We need to know how frequently we have to do the intervention. So things might, you know, adjustments need to be made for any tolerance levels or anything like that, or things need to be lubricated, and what we actually do on what basis. So, you know, how frequently do we look at testing and intervention? That should hopefully be enough to enable a checklist to be created. So a maintenance engineer can look through the checklist and go through the various bits on whatever schedule is required to ensure that they can conduct all the required actions at the right times. And as we've said previously as well, it needs to be monitored on an ongoing basis to make sure it's still suitable and sufficient. There are certain specific requirements for certain issues on a machine. So we're looking at potential single points of failure and so on. And that can be looked at in certain aspects of basically the electrical system or any software for lubrication, pipework and hose assemblies, any remote maintenance that's conducted, and the replacement and spare parts, etc. So if we look at specific requirements for the electrical systems, then we need to be looking at things like the OEM's recommendations, the environment and the location of which the machine's used in, its operational life, but also safety related parts of control systems and what impact it might be if one was to fail. So we would look at typically the hierarchical approach for that. So we would start off with any low-level interventions, so visual inspections, pre-use checks and awareness of change. So has something moved, changed or been taken out of a machine? So that we've then got the operational testing. So it might be, you know, periodically test an e-stop or an isolator to make sure it will switch things off and so on, that the lights come on to say that it's in a certain mode or something like that. And then further on, as well as the type A and the type B checks, we do the full calibration testing. We might do stop times, as we said, for the positioning of things like light curtains or scanners and so on that you might have as a safety related component on a machine. That all combines into parts of the electrical system. For software, there are details given in the standard about the maintenance, the modification, the changes and things for both firmware and application software, and also any parameterization, so changing of tolerance levels or speeds or recipe values or anything like that that might be in there. And quite importantly now, and especially with the advent of the new machinery regulation that's been launched, that also includes looking at details around cyber security, so ensuring that, you know, we are not susceptible to any malware, viruses and things being put on there, how we can get monitoring information and diagnostics out of a machine, and what impact the maintenance or modification of any software might mean. So we need to ensure that we have backups, that we can always take a backward step and put the old thing back in there. Can we simulate what these changes are going to mean before we actually do that? One of the key things is that we need to ensure that the person is competent to actually change safety related software. A lot of this is password controlled and things like that within safety programming, but we need to know what was changed, who changed it, and so on. And things like checksums in programs are a great way of being able to keep the records and things in line for the bits that can be modified and changed within that. There are also requirements for remote maintenance, that it must again be controlled and documented. We must have procedures for the authorization and things like that. So again, only certain people can do that. But also, if it's done remotely, then we need to have somebody local to the machine to be able to oversee what's happening, and any local machine stops and any other safeguards and things like that need to be able to be continue to operate as the remote maintenance is being carried out on the system. But also, a key point to note is that any loss of communication or any unintended interruptions or cyber attacks and things like that shall not affect the safety of the machine. So we must still have the functionality maintained and things like that when looking at remote maintenance. So that basically brings us to the records and things that we should have for maintenance. We should have details of the machine ident number, so serial number or something like that. When the maintenance was done, what maintenance was done, including what parts and things might have been changed, replaced, repaired, etc. What inspections were done, and a record of the sign off and the handover and maybe putting the machine back into service once it's done. So it can be either a paper-based system or a digital-based system, which is great for getting historical data and trends and things like that within there. And ideally, where we have pre-use checks and things like that, the sheet should be located next to or local to the machine that it actually is required on. So that brings us to the end of the section on maintenance requirements and the details of, or some of the details that are given in the new standard 14200. And one of the key things to allow us to maintain equipment in a safe and controlled manner is something called LOTO, so lockout tagout. So we need to ensure that we have a policy, a procedure, or a process so that we can lock or fix a lock onto an isolating device and put a tag on there so we know what it is, so that we can, in essence, ensure the machines are prevented from starting unexpectedly, or we can ensure that we don't have any stored energy or anything like that in a machine. And the key thing also is to ensure that we verify that the power has been dissipated. Now, it might be electrical, pneumatic, hydraulic. One key one that is often missed is gravity. So you may stop a machine in its at the top of its cycle or something like that, but you ensure that if you then take the power off, that it doesn't creep down under gravity and cause a hazard to somebody that might be then doing some maintenance work or something on the machine itself. There are many accidents that have occurred because of incomplete or inadequate maintenance lockout tagout procedures that have been put in place over the years, and it might be that this is because it's the wrong equipment that was isolated, or the wrong labeling's been put on there. There's been some sort of unexpected startup or something, or any stored energy or anything there has not been fully dissipated and allowed the machine to move in some unexpected way. So we need to ensure that whatever policies and procedures that are put together are robust and they are followed diligently. So we ensure that the people that use the LOTO are trained in exactly what to do and how to do, and do that without any any sort of manipulation or bypass, because it could be an issue that basically it leads to potentially fatalities and things like that, depending on the nature of the particular machine. So we need to make sure that just unplugging it or switching it off is not something that makes it safe. We need to isolate the things that are done there. And we need to make sure that in doing that, that we don't have any hazardous materials released. The machine can't start or doesn't start up unexpectedly, and certain parts just don't move and things. So, as I say, gravity is a key one there, where things have just over time fallen from a hold position or a top position and caused issues. So we need to ensure that the system is suitable for what we're doing, the procedures that are required to be done. So is it a daily task, or is it a routine or a scheduled task or something like that? That the person doing it knows what to do and how to do it and what needs to be done. And also if there's any change or anything that needs to be done over a period of time, and any contingencies that need to be put in place if certain things happen. So LOTO is obviously the key thing that is put in place to try and prevent accidents from happening whilst working on a machine. So the ultimate goal is to protect the health and safety of the employees, but a secondary goal can also be to protect the equipment, because you don't want certain things to happen during maintenance, where the machine may go into a condition where something moves or does it without part of it being in place, which then can actually damage the machine itself. So we need to ensure that we have a correct policy and procedure, that the people are trained and it's communicated and out through the system, and also that somebody makes sure and supervises it to make sure that it is actually being followed. And it can ideally be incorporated into a permit to work system, so it's controlled on, so only certain people having access to do certain things and certain functions of maintenance as you go through. So the function of the lock itself is physical control, so that nobody can inadvertently turn something back on because it's locked off and you're the one that has the key. The function of the tag is to let people know who's actually locked it off, so who's authorised to do it, who's carrying out the thing, and how long is it going to be switched off for, but also if they need any more information on things like that, who to actually contact for that. The isolation device itself should physically disconnect the hazardous energy, where practical also release any stored energy or dissipated. So we might vent any pneumatic systems or something like that. We must be able to put multiple locks on. If there's multiple people going to be working on there, we need to have a hash that has the option of having multiple padlocks or something like that being put on. We need to enable the fact that we can verify that things have stopped. So you may have heard the term lockout, tag out, try out, so to ensure that it won't physically do any movements or anything like that when you've done that. It might be that you need to put mechanical restraints and things in there, so sort of locking posts and or pins or something like that in there. And also that the isolation device is at a height that we can reach. So there are requirements and things that we need to be able to get to the actual isolator to lock it off as required for the task. There are requirements again on the actual tools and things that are there. So you will have specific looking devices and things like that that you can see that are used purely for lockout, tag out. They must be singularly identified. They must be the only devices that are used for controlling the energy, and they're only used for that lockout purpose of the maintenance requirements and things that they've got there. They have to be able to withstand the environment that they're in. They must, for example, the tag that's on there must be weather resistant. If it's, you know, outside on an access ladder or something like that, it needs to be a waterproof format so that it doesn't deteriorate and we can see the details that are on there. If there are any chemicals or acids or anything like that, they must be able to withstand any contact or splashes or anything like that that might come from it, so that we can ensure that the information on the actual device and the tag itself is readily available to be able to easily read and understood. It could be a multiple different type of things that are used. There are many different things that might be required as part of the LOTO policy. So it could be locks, tags, chains, weld wedges, pins, fasteners. There could be an actual personal lock that's given to a maintenance engineer that he has his own, rather than one that he would take from a LOTO station or something like that not there. It may be that we take certain enabling devices and things off a machine and put them in a lockbox that's again padlocked off, so that they can't get access to things to start up a machine whilst it's undergoing its actual maintenance procedures. There are various things, as we've said, that they need to be suitable for their use. So we need to be ensuring that you can't accidentally remove it. It's attachable by hand, so it's something that you can easily get on there. It's self-locking and so on, so that you definitely, it's non-easily releasable, that you need a tool to remove it, so a key for a padlock, etc. And it needs to have some sort of legend or something on there so that people know not to start, open, close, or try and operate a machine whilst it's undergoing its maintenance requirements. There are things that Pilz can help you with regards to a LOTO policy and procedure. It's a service that we have that we can provide that is put in to ensure that your maintenance requirements and things that you have for the machinery that you have is done in a controlled and safe manner. And that would involve looking at an analysis of the existing plant, what your existing policies, procedures and things like that may be. If needs be, produce a new procedure that is of a comprehensive control and ensuring that it complies with the requirements and things, but also to train the people in how to use the LOTO devices and the new procedures and things, and controlling that hazardous energy. It's actually done as a two-stage process, and the first stage is to actually do the analysis, so look at the machine and find out what controls are there. Is there a need for electrical, pneumatic, hydraulic chains to lock something out or something like that that might be required to hold things in position? And this will be dependent on each individual machine and the requirements for the power sources that it has with it. The second stage is to actually then produce the procedure, and it's great to have something like a graphical image that shows you where the isolation points are. It's easy to follow. You know what you need to isolate each part. So it might be that you just need a padlock to isolate an electrical isolator, or it might be something mechanical or a load that's in a raised position that you need to use chains to hold it all in position, and how to do that, and everything that you've got within that particular requirements. It might be that there are only, depending on the task, only certain things that you need to isolate. So it might be isolating a certain section of a line or a cell or something like that that needs to be done. So it's how to just isolate the certain parts that you need to allow that particular maintenance task can be carried out. And the key thing also as well is to know not only how to take it out of service to do it, but to then put it back into service. So the actual the opposite of lockout, tag out, but putting it all back into service, and it might be that you need to do it in a certain manner, in a certain way, to ensure that certain things happen at certain times. So that is our review of LOTO. There is much more to it, and as I've said, there Pilz have a service that can help you with that should you need it. What I want to look at now is certain aspects of control and things like that that will provide a safe maintenance solution. And one of the things available from Pilz is the identification and access management system that we have. So a lot of things that we have with LOTO is putting machine into a safe condition, locking it out, controlling it, putting it in there. One of the key things is that you need to, if it's a full body access, you need to have a key or a lock that you take with you, or you lock something off that's in there. The system that I'm going to show you on the little video clip next is something that allows you to do it in an automated manner. So as a result, with it being an electronic and automated manner, you don't necessarily need to have all of the lockout tags and labels and things like that that we have just looked at in the previous slides. So if we look at the requirements of going into a cell or a machine, we can basically control who has access to get in there. So the key is programmed with a user's specific code to allow him access. So only certain people can do it. So he can request to go in, lock the system off, or stop the system going, do what he needs to do within that machine, because he's got his key that gives him the specific access and the permissions to do that. It may be that we can have multiple people coming in from different access areas or different ways into a machine to do different things at the same time. The other benefit is that you can go out of a different way that you came into a cell. So you can log out, start it there, but you can't restart the machine because there's already somebody in. Also, we can give identification if there are any blind spots or anything like that. Because of multiple access points, the last person out can go and check that the blind spot's clear. So in essence, a form of preset reset. So it has a specific time to allow him to then get out of the machine, again, in a controlled manner. So he can press the button, unlock the door, get out, and then with his permissions key, put it back into a controlled start. So then he's authorized to actually start it and put the machine back. This is the added benefit of it's his specific key. So whereas in the past you've had mechanical keys that anybody can use, with this it's a specific key for a specific person. It's easy to be able to reprogram it should it needs be, and you can have multiple functions and permissions and things on keys for certain groups of team members. So operators can have access to certain parts and operations, but they can't get into certain full body access cards or something. On the maintenance people can do that, and you can see on the screen there the various levels of integrity that we can build the system to. So what we might also have is the need to put a machine into a certain mode. So it might be a cleaning mode or to inch it round or something like that, that we have a requirement to be able to carry out a certain function rather than the normal run mode. And again, here we can use a solution from Pilz that shows here the fact that we can have, again, these programmed keys so that certain people are only allowed to do certain aspects. which can be combined with third-party kit. It doesn't have to be all Pilz kit. We would appreciate it if it was. But there are predefined functions and things in there that you can use to either have mode selection buttons or things like that, or some even form of HMI that can be used to control it. So again, the operator can put his token or his card up to a reader. We then communicate with the device and he can select a specific mode. So it might be that he needs to go into setup or something like that, but he only has access to that. But the maintenance engineer who needs to go into service something can go into his own mode, but only his key will allow him to actually do that. So again, you can control different people having different access to do different functions, to do different things that might be for setup, for maintenance, for repair or cleaning or anything like that that's actually on there. It might be that we need to again have certain requirements to be able to again allow just certain people to get in there to do certain functions. So again, another variant on the access management systems, where an operator can put his various things in. So you can see that he only has access to read certain values, but a service engineer has extra things that come up maybe on a screen or something that allows him to go in and change certain parameters or something that it might be if he needs to modify something or make a change on that. And then also, if you need access into an actual machine area or something like that to conduct something, again, you can have these same keys rather than being able to have to go through a lockout tagout policy or procedure. We can do it in an automated manner, so that only when the authorized person takes the key out can they get access to go into an area and do whatever may need to be done. They also then are the only people with their key that can allow the machine to be restarted and put back in to a production environment. Again, it is optional that you can have a full solution provided by Pilz, or it can be used in combination with other manufacturers' devices. One of the things that we mentioned earlier is about cybersecurity and only allowing certain people to have access from a remote point of view and not prevent, or to prevent from having any malware or viruses or anything like that transferred onto a device. And again, a further solution from Pilz will allow you to control that to a degree. And that is done using a security breach device. So again, only personnel local to the machine. As you know, we've got to have somebody there that can say, yes, we're going to allow somebody to put, for example, a USB device in, or open up a network port or something like that that you have there, so that it can be either a firmware upgrade by a manufacturer or something like that who's not actually on the plant. But also it might be that there's a software change or an update or something like that. So again, if it's interrupted by somebody local, that we can then stop any requirements and things like that, or modifications that are being done. So again, we have secure access control and things like that to be able to conduct remote maintenance operations and things if needs be. So within those few short videos that you've seen there, there are a number of solutions that will assist with a sort of modern electronic version of lockout tagout, so that you can get a high level of integrity in the actual controls. It can be programmed to ensure that everything stops, so nobody can forget to stop a certain part or switch a certain thing off. We can program it to ensure that all energies are dissipated and we can have check valves and all sorts of things in place there and monitor the position of those and so on. We can prevent unexpected startup because people are logged into a system. We can obviously protect the health and safety of employees because it's automated. We're not relying on human nature of people trying to do something or indeed somebody trying to bypass something. We can protect the equipment from damage, so it has to follow the programmed procedure. We have full traceability, so we know who did what because of the data logging and such. We're only allowing certain people in to do certain tasks. We can program it so that the system is only available to be in a certain mode or whatever for a certain period of time. And the keys can be configured that if you, for example, had a third party doing your maintenance, you can give them an access key that's only valid for the day that they come in, or the week, or whatever it might be, that they come in to do that maintenance work. We can ensure that people go and check blind spots. We have the cyber security possibilities there. We're using the security bridge device. You don't need to rely on somebody filling out a tag and attaching it with the lockout device and things like that. And potentially it can be considerably less expensive, but also very much more flexible than certain other systems and things that are available. That basically brings me to the end of this morning's webinar. If you want to look at some more solutions and things that are available from Pilz, there is our digital showroom on the website. If you scroll down on the landing page, you'll see the picture at the top there. If you click on that, and then more specifically the top grey box on the right, which says Component Systems and Solutions, that will then take you into the virtual machine that you can see on the bottom, and you can see how you can interact with various aspects of access control and things like that, and the solutions that we have available. There is obviously the option to go to our webinar channel and watch this webinar again, but also all the previous ones that we have on there that cover a vast range of machinery safety topics that you can view. And basically, that's me for today. There's nothing more really for me other than to say that I hope you have found this morning's session of value, of interest. If you do have any requirements for potential solutions or LOTO policies and procedures and reviews and things like that, then please don't hesitate to contact us and we can talk to you outside of this. Hopefully my colleagues have been able to answer any questions that you have within the session from this morning. So finally, I'd just like to wish you all a great weekend, and I look forward to seeing you on the next Pilz webinar.